Alright, in the last video we were working on limits and we saw where we just plugged it in, the x, and it worked. And then we solved it algebraically, and since algebraically that can be a little bit hairy, let's try to do one more, and then we'll do one where, well, this one gave us a 0 on the bottom, but we'll do one with a different technique other than factoring out the the quadratic. Alright, so let's see, I got one here. Let's do a different color, see if that's not too ugly. Alright, oops. So we'll do the limit as x approaches 169, square root of a square root of x minus 13 over x minus 169. Alright, so naturally if you plug in 169, you get 0 on the bottom and you get a 0 on the top, so this would give us 0 over 0, which doesn't work. But again, we can factor it like we did in the last one. So right, like right here. Oh, that's nice. Maybe I'm pressing too hard. Alright, so this one, because that's what we did here, and it gave us two like terms. We crossed them out and then got something that was more appropriate to helping us solve. So this one is going to be pretty similar, I think. Let's see, so we end up getting, well, you can't really factor the top out. So what times what equals the square root of x. We could do, the fourth root or whatever. But let's do, so we know the top, let's just leave the top the way it is. Let's see if we can't get something from the bottom. Because the square root of x times the square root of x is just x, so that would, let's try to add this one, just like we did in the last video. And then multiply that, well, that'd have to be a positive, right? Negative 13 times positive 13 is negative 169, and since there's no b term, it's just the same equation, 1 minus with 1 minus and 1 positive. And you can check it by, foiling it. Plus 13. Alright, so these two cancel out, right? Like that. This ends up being a 1. So we end up getting 1 over the square root of x plus, why is it keep doing that? Plus 13. Maybe I hit the little knob on the side of the pen. Alright, so that gets us, oops, there you go. So that gets us 1 over, looks like 1 over square root of 169. I'll just type it out. Plus 13. So that gets us 1 over 13 plus 13, right? We're not doing the negative, otherwise we get another 0. So that wouldn't work, so we'll just keep it positive. And that's what the answer key says, 1 over 26. So there's no worries. Alright, there's another problem I wanted to do. Let's see. If I can find it. We don't use algebra. I could just make one up and see where it goes. Like, I know they do a infinity line. Yeah, let's do one of those. Alright, so if you get a limit that goes to, and they do a lot of infinities and zeros, the limit as x goes to infinity of, let's see, x squared plus 40 cubic simple terms. It's going to do 400. 400x plus 1. That's fine. And then the bottom I'll do x squared plus 19x minus 70. And you're asking, okay, what do I do? How do I do this? I mean, I really literally just made these numbers up. What two numbers, you might ask? Multiplied together equal 1, but when added together equal 40. You know, if you want to factor out the top, what two numbers multiplied together equal this, you know. But I didn't do it like that. I'm just trying to teach. I'm trying to show you a different way of doing it. This is a different type of limit problem. In other words, that you take the two highest powers and then you knock out everything else. So like this is the highest. There's a 2 here in the numerator. So we just end up crossing these out, because as this goes to infinity squared, this goes to infinity, you know, at, you know, square root the same pace. Although it's times 40, but if you're talking about a trillion, you times it by 40, it's not a big deal, as opposed to a trillion times a trillion. And you do the same thing with the numerator. So this gets knocked out. You know, if this was a 2, we have the same base, and then we can, you know. So, but what we do is, okay, so it's like if this goes to infinity squared and this goes to infinity squared, what do we get? Well, we get 1. And I know it sounds kind of funny, and it may not seem like it makes a lot of sense, but well, let's do one or two more problems, and we'll see if it doesn't make sense. All right, let's do another limit. As x approaches infinity of x to the 4th over x to the 5th. I could just leave it like that, but I'll just do plus 5 minus 6x. Same thing. We got a power of 4 here. The 5 obviously is not going to do anything. Power of 5, this power of 1 isn't going to do anything. I mean, it's going to be going at such a slower pace, you might as well just leave it behind. And what do we get? Well, we get this one, and the same kind of, you do the same thing as you would for the denominator or the numerator. This is a power of 5, and this kind of cancels out really cancels out the power of 4. You know, so as this approaches a really, well, I should do it maybe 5 times. Really large number. This one goes really large, or really large. And so this one is a lot bigger, and it goes an infinity times faster. So it actually ends up being 0. Alright, because when this gets, if you get a denominator, say it's like this, and you get like 1,000 or trillion, you're pretty much getting, should have put more commas there, pretty much getting 0, right? You're getting such a small number, and that's exactly what's going on here. You know, what you could do is you could factor it out if it makes it easier. You could say, oh, okay, you know, x to the 4th over x to the 5. Well, you know, I can cross this out. That's a 1. I can cross this 5 out. So I end up getting x, 1 over x. As x approaches infinity, and I basically get one of these or whatever. So, a couple more. Alright, so that's good enough for this one. I'll do some more in the next video, and hopefully it'll help you out. And the whole point is really just to teach yourself calculus, because that's pretty much how I learned, and you know, it's kind of fun, and so it's free. So, and that's it. All right.